Hello everyone, this is the first lesson recording for IM2, November 16th, 2020. So we started off by doing some decimal activity, just cut number 1 and 2, just warm-up problems. And this is the first warm-up problem where you're told to solve for x, round answer to the nearest tenth. So what do we know? What do we need to know? We are given the angle measure here, and we're given the side measure here, and we're trying to find another side measure here. So the first thing I would do is identify the sides. I have my right angle here. That means opposite to this is hypotenuse. And then relative to the reference angle, this is the opposite side. This is the opposite side. So which is the trig ratio that deals with opposite and hypotenuse? That's sine theta. So sine of 40 degrees, that's the angle measure, is equal to opposite, which is x, divided by 24. Okay, and if I look at sine of 24, that's 0.4067 is equal to x over 24. So what do I need to do? I see that the number is x is being divided by 24. That means I need to multiply both sides by 24. Okay, I'm going to use parentheses so that I do not mix up decimals with multiplication. Then x is 24 times 0.4067. So I get my x to be 9.7608 when I multiply 24 times 0.4067. Now, part of the reason I want to do this problem is because of the rounding issues. When I'm looking at your homework, I am finding that many of you do not know how to round, and you do not know how to round to the whatever you're taught. So it says, round your answer to the nearest tenth. What does that mean? So here is my decimal place. This is my decimal point. The first digit after that is the tenth. Okay, the second digit is the 100th. And the third digit is obviously the thousands. And then 10,000s and so on. Okay, so that means we want it to be cut off to the 10th. That means we want to cut off after the 10th. That means the first decimal place. We want to cut it off somewhere here. Okay, that means in order to do that, we don't just cut it off right here. Before we cut it off, we need to look at the next digit. If the next digit is 5 or greater, then you need to change the previous number 7 up. Okay, so now because 6 is greater than 5, so we need to change this up, and so that means this becomes 9.8. X is equal to 9.8 to the nearest 10th decimal place. Okay, let's do the next problem. Warm up 2. Solve for x, round answer to the nearest tenth. Okay, again, the first thing I will do is identify my sides as this is my right angle here. This is my right angle, so that makes this side the hypotenuse. And here is my reference angle, and the side we're given 20 is right next to it, so this becomes the adjacent. So which is the trig function that deals with hypotenuse and adjacent? That's cosine. So cosine of 77 degrees is equal to adjacent over hypotenuse. Okay, so it's hard to see the number here, but I believe cosine of 77 degrees, that's the angle measure, is 20 is what I'm reading. 20 over hypotenuse is x. So now that we see the x is the denominator. In this case, you need to multiply both sides by x first to bring the variable x to the top. This cancels out and you are left with cosine of 77 is equal to 20. And then from here, I need to divide both sides by cosine of 77 degrees. Yes, I can use the trig table to do that, but I can also do that at the end. So that's going to be 20 over cosine of 77 degrees. So that's going to be 0.22450. 2250. So then becomes 88.9. So then I get my answer to be 88.908229 dot dot dot. Okay, again, we're told to round our answer to the nearest tenth. This is the tenth, right? This is the tenth. This is the hundredth. This is the thousands. That means we need to cut it off right here. But before we cut it off right here, we need to be looking at the next digit. Okay, so the next digit is 4 or less. That means we do not need to round this number up. We just leave it as it is. So the x is 88.9. So, and that's what you should enter here, 88.9. Okay, then I want to go on to discussing some common homework error. And please do not feel bad if this is your homework that I am displaying. Believe me, if your homework was the only one that I'm seeing like this, I would not be showing it. So here is a homework that has been turned into me. One of the things I wanted to show you is that the fact that this is really disorganized. I see number 1 being shown here. And then there is, I think, where is number 2? I think number 2 is here. And then number 3, number 4. Number 5 is somewhere, but I don't see it right now. There is number 6. And then there's number 7 and number 8. And I believe some of this could be number 5. I'm not sure. But anyway, I hope you realize that, when I'm grading your homework, this is kind of irritating. Okay, so when part of math is communicating your work clearly. And when it's disorganized, first thing is when you're looking back, you're probably not going to be able, this is probably not going to be very meaningful for you to be looking back to see what you did, if that's going to be at all helpful. Okay. Another thing with this student is that this student did not check the answers at all. Okay. So there's no way of knowing, am I doing it correctly? Am I not doing it correctly? And I can tell you some of the answers are correct, some of them are not. But he has no way of knowing which one. He's just getting it done. All right, so then if we sort of zoom into this area, this is the problem I also want to talk to you about. The first thing is this diagram that he just redrew. He copied from the worksheet, but it's pretty sloppy. Sloppy to the extent that this triangle, this does not look like a right angle. He correctly identified hypotenuse to be across from the right angle, but this does not look like a hypotenuse to me. To me, this looks like a hypotenuse just from the diagram. So yes, he marked the right angle, but you want to draw as close to the proportion as possible, because that way you're going to be able to see which is the shorter side, which is the longer side. Is your answer reasonable after you get the answer? Does it look completely off? Or so on and so forth. If it is just a random triangle, you're not going to have that feedback. Okay. Another thing that I wanted to show was this sine is equal to 35 over 37. Its true sine of theta is equal to opposite of a hypotenuse. So opposite, he identified it as 35. hypotenuse identified as 37. So 35 over 37 is correct. It's the ratio is correct. However, you're never going to see sine by itself or cos or tan by itself. It's always going to have either a theta right there or some angle referring to an angle. So in this case, it will be correct to say, because we are actually referencing this angle from A, angle A. So sine of A is equal to 35 over 37. So that's what you want to write. You never write sine, cosine, or tangent by itself. It needs to be always have some sort of angle measure or angle notation. Another example of the homework that I wanted to show you was this one. This student, I really like the way she's showing her work. Okay, she's copying down the whole question in its entirety. She's also writing down what tangent of C is. It's always opposite of adjacent. That's great. Okay, but what she's missing here is that C is equal to 20 over 29. When you just write C is equal to, you're referring to the angle measure C is equal to 20 over 29. That's not true. This is not the angle measure, this is the ratio. So what you really need to have is tangent of C, which is what you had as a question to begin with. So tangent of C is equal to 20 over 29. And again, this is should be sine of A is equal to 35 over 37. Okay, so then I quickly went over the homework number 22 answers and 23 answers. Okay, so number 2, tangent of C is 20 over 21. Tangent of A is 3 over 4. And sine of A is 21 over 29. The next page. Cosine of X is 7 over 25 for number 8. And number 10, X is equal to 3.57 to 2 decimal places. X is equal to 3.06 and X is equal to 28.56 is what you should have. And then for homework number 23, for B, theta is equal to 63, or the question mark angle is 63 degrees. D is theta is equal to 68 degrees. F is theta is equal to 24 degrees. And H, theta is equal to 18.5 degrees. Oh, I should have not done it to the 10th degree. All right. Now, I know that some of you had problems with the application problem, so I am going to go through it. Okay, so here we go. The first thing is you need to draw your triangle, and this is where I am standing. And when I'm looking up to the tip, the angulation is 53 degrees. To the bottom of the Snoopy is 29 degrees. That means I have two different triangles. So then I calculate for my big triangle, I calculate the height, and I calculate that to be 79.62 feet. Okay, so that is how high the tip of the Snoopy is above ground. And then there is another triangle, the pink triangle, that tells me where the foot or the bottom part of the Snoopy starts. And that tells me it's 33.26 feet. So then to find X, that's the height of Snoopy, I need to subtract H minus Y. And that leaves me with 46.36 feet, or approximately 46 feet. The next problem, the triangles look like this. 40 degrees for the beam, 8 feet. And from here, you need to figure out what beam length is, which you get to be 12.45. And then from the second diagram, you get 60 degrees, and you have the height of from ground to the tip of the beam, and we're told that there's 2 more feet there. So then you can figure out how high the wires are from the ground, and you figure out the ground wires are 12.78 feet above, and the beam